Sid? Sid?
Yeah, what is it, kid? You want an autograph?
Well, sure, but I was wondering if I could ask you a question.
Hand me that pen there. I'll sign your napkin.
Here you go.
What's your name?
Logan.
To Logan. Thanks for bothering me after my piano act and making me miss my bus home. O-M-E. Sidney J. Sheinberg. E-R-G.
Thanks. Anyway, about that question.
I know what you're gonna ask, so don't even bother. Here, let me sing you a song about it before the bar closes here. Okay. The Charge Conjugation Parity Violation Song by Sidney J. Sheinberg. 2, 3. There's matter in my trousers. There's matter in my hair. There's so much freaking matter, it's damn near everywhere. What isn't making sense to me is how it all got there. But seriously, what puzzles me is why I even care. Physicists love symmetry. It's simple and it's nice. For explaining all phenomena, just a couple rules suffice. But when you get down small enough, it's very plain to see that certain little particles create asymmetry. Charge conjugation, parity violation, a mystery to all involved. It might explain asymmetry and help us all begin to see just how this universe evolved. Charge conjugation is basically the process by which you turn a particle into its opposite or antiparticle. Positive becomes negative, negative becomes positive, charge conjugation. And parity, well, all that is just a particle's position in space, where it is, XYZ coordinates, you get me? Well, when you have particles decaying, you should have just as much matter created as antimatter, antimatter being the opposite of matter. Well, the antiparticle usually does the exact opposite of what the particle does, you see, so its position and charge will be opposite, thus the law of CP symmetry. But matter and antimatter would have to be created in equal amounts, right? Cancel each other out, conservation of matter can't create stuff out of thin air, right? Right, okay, but just look around here, what have you got? Matter. Whole buckets full of the crap. Where's the antimatter? It's not here. Pretty much the only place we can see it is when we make it ourselves by smashing particles up in proton colliders. That's funny, there should be just as much antimatter as there is matter. We don't know for sure if there are whole galaxies of this stuff floating out there farther than we can see, but it's pretty unlikely. So where's the fundamental asymmetry? Now, sometimes, and this has been observed, when a K meson, or kaon as the kids are calling it, decays, you get a CP-violating asymmetrical result where the antiparticle behaves differently than it is supposed to. The kaon, instead of decaying into a 2-pion group and a 3-pion group, which would be a symmetrical law-abiding result, it will decay into 2 2-pion groups. What the hell? Don't ask me about that now. We don't know why it happens, but it does. So here's this asymmetrical reaction stuck in the middle of all our beautiful symmetry, okay? Now, apply this asymmetrical tendency to the first few seconds after the Big Bang, round about the vacuum era. Who knows? Maybe this could help explain why there's so much matter around here, but no antimatter. Sing! Charge conjugation, parity violation, a mystery to all involved. It might explain asymmetry and help us all begin to see just how this crazy universe evolved the way it did. Does that answer your question?
No.
Well, it's all theoretical.